And moving on to problem number 5 on page 6. A 1500 Newton force is exerted on a 200 kilogram crate to move it across the floor. If the coefficient of friction is 0.25, what is the crate's acceleration? Okay, so we have a crate. And we're exerting a force across the floor. Okay, so it doesn't really tell us whether it's push or pull. Let's say that we're pushing it. It doesn't really tell us the direction either, whether it's to the right or to the left. Let's say that we're going to be pushing it to the right, and so therefore that's our applied force. What is the opposing force? Obviously it's a frictional force. And what kind of friction is it? Is it kinetic or static? Well, we know that we're going to be trying to find out the acceleration of the object, and if that's the case, assuming that the object is moving at all, hey, you know what? We know that we're going to be working with a kinetic friction. Okay, so we have our free body diagram right now. Let's pull out all the given information. So 1500 Newton force is exerted. Okay, so what is that telling us? Hopefully you're saying to yourself by now that that's our applied force. It's equal to 1500 newtons. Is exerted on a 200 kilogram crate. Okay, and that will be our mass. Okay, and the coefficient of friction is 0.25. What is the crate's acceleration? So that's going to be the acceleration in which direction? Alright, and I believe that this is all the information that we have. Okay, let's do this here. Let's figure out what our force due to gravity is. So the force due to gravity is equal to the mass times acceleration due to gravity. And here we go. And the force due to gravity is equal to 1,960 newtons. Okay, and let's set up our two force equations. Alright, so all the forces, so let's say that our positive direction is going to be upwards, and let's say that our positive direction is also going to be to the right. The reason why is because that's the direction that the object is moving in. It's moving to the right. So, we're going to be working with all the forces in the y direction, all the forces going upwards minus all the forces going downwards, is equal to mass times acceleration in the y direction. Is the object moving up or down at all? No. So therefore the acceleration in the y direction is equal to 0. 0 times any number is equal to 0. Okay, so now we're going to be dealing with all the forces in the x direction. All the forces going to the right are going to be positive, minus all the forces to the left is equal to mass times acceleration. Well, the acceleration is what we're trying to find right now, so we're going to just drop this down. And that should make sense. And that is the setup for problem number 5.